Welcome once again to today's lesson where we look at physics practicals and also other subjects, biology, chemistry, and what have you. We are basically going to be dealing in the practicals and the theory as well. You can subscribe at Mto Online on YouTube, TikTok, subscribe to Mto Online. So today I'm going to take you through a UCE sample scenario of physics paper 2, paper code 535/2. That is the physics paper 2 UCE. We are going to have a simple guiding question, scenario based, and then we see how we handle these scenario based questions. The question is already upshared there, but I can briefly read it. It says, while setting up a projector, the lens fell and got broken. According to the specifications written on the projector, it can use a lens of focal length 8.0 centimeters to 12.0 centimeters. A lens P was brought to replace the broken one, but the operator was not sure if it had the same power. The task to you as a physics learner of new curriculum: as a student of physics, carry out a scientific investigation to determine the focal length of a lens provided and advise on whether the lens board can be used in the projector. Now, in this question, they've given us a scenario where someone, while setting up a projector, the lens of the projector got broken, and they had to replace it under normal situations. Now, they bought a lens, but on the specifications of the projector, it had that it can use a projector of focal length from 8.0 centimeters to 12.0 centimeters. Now, the operator has got a new lens P whose focal length is not known. They want you now, you as a new curriculum physics learner, to carry out a scientific investigation and tell us whether the new labeled lens P can honestly be replaced to the broken one. Now, straight away, we are going to look at how we align these experiments. Now, we begin with the aim of the experiment. And the aim of the experiment will definitely be got from the scenario itself. Now, your aim, it's like the purpose of the experiment. Why are you carrying out this scientific investigation? Because you need to know the reason why you're doing this. So this reason or the aim or the purpose, it's definitely got from the task. As a learner of physics, carry out a scientific investigation to determine the focal length of the lens provided and advise on whether the lens can be used in the projector. So now, our aim of experiment, we shall have aim of experiment. Aim of experiment. Remember, this is an experimental report, a laboratory report, a lab report. You supposed to go in the lab and then you come out with a report to advise us on whether we can go ahead and use the new labeled lens P, or we go and buy another lens depending on your results. Because according to the specifications of the projector we have, it's that it can only use a lens of focal length from 8 to 12. So we want to determine whether the new labeled lens P has a focal length of power 8 to 12. So aim of the experiment, and our aim, we shall use a scientific investigation, a scientific investigation to determine the focal length of a lens P in order to replace the broken lens of the projector. Now, when you look at my aim of the experiment, it has the aim and it has the reason. When you simply state the aim without a reason, you only score a 2. You have a score of 2. So I'll be sharing on how we score this. Now, when you state the aim of the experiment plus the reason, you have a score of 2. But again, when you simply state the aim of the experiment, for example, you say a scientific investigation to determine the focal length of a lens and you put a full stop here, you have a score of 1. And it is very, very vital to state the reason such that you can now scoop all the scores that you are supposed to get on that part. So aim of the experiment, scientific investigation to determine the focal length of the lens P in order to replace the broken lens of the projector. We have the reason and we have the aim. So you have a score of 2. Now, from aim of the experiment, this is now a laboratory report. We now go to the variables. And under variables, we have 3 variables. We have the independent variable, then we have the dependent variable, and we have the controlled variable. The dependent variable will depend on the independent, and then we finally have the controlled variable. Now, when you look at this, in the theory, you learned about how to determine the focal length of a lens, where you can use a white screen, a lens, and then a wire gauze screen or cross wires, and you realize that you will always have the object distance and then the image distance. The image distance, which is denoted in most cases with the letter V, and then the object distance, which is denoted by U. These letters can anyway change depending on, as long as you let them anyway. This is new curriculum where we discourage cram work. It's about understanding the concept. So these are just letters where you can use still your own letters. However, some letters like letter O can be avoided because you can mistake them as a 0. So much as you are free to use any letter of your choice, as long as you've let them, avoid some letters like I, because I you can write it and you can mistake it to be a 1, and letter O which can be mistaken and you take it as a 0. Now, variables, we have the independent variable. Now, according to this experiment, the independent variable is the object distance, and we can call it U. This object distance is just the distance between the cross wires and then the lens. The lens in this case, wow, we are going to look at a convex lens anyway. Now, the object distance is independent, but the image distance is independent. So the image distance will depend on where the object is placed. It's, for example, you standing in front of a mirror. The nearer you stand next to the mirror, the bigger or the larger your image becomes. And the further you stand away from that mirror, still the more diminished your image becomes. That means that the image, the size of the image will always depend on the size of the object, and so applies to the distances. So that means the image distance is it is dependent on the object distance. And in this case, it automatically shows us that the object distance u is an independent variable and the image distance v becomes the dependent variable. Okay, so now our dependent variable is going to be image distance. Image distance, we can call it v. And then we also have the controlled variable. Controlled, just from a mere hearing of the word controlled, you can increase, you can reduce. When you look at this experiment, this is a light experiment, and so the intensity of light that we can use can be controlled. You can decide to use one dry cell, you can decide to use 2 dry cells. So that means the intensity of light can be controlled. You can increase or decrease. So now in this experiment, since we are going to use light, we are going to take the controlled variable to be light intensity. Now, light intensity, when you purely state the variables correctly, all of them, you have 3 scores. Here you had 2 scores for aim of the experiment plus the reason, and now on the variables you have 3 scores, one for independent variable, dependent variable, and controlled variable when you state them correctly. Now from there we shall have hypothesis. Now hypothesis is just a statement of prediction of what you predict to come out. What do you, according to your knowledge, from the knowledge of physics that you have so far, what do you expect to have as an outcome? Of course, basing on the specifications of the projector, you can expect or you can make some predictions of what will come out. Okay, so now our hypothesis, you can have one, you can say the focal length of the lens, we've called it lens P, is the focal length of the lens P is approximately 8.0 to 12. Is approximately 8.0 to 12.0 centimeters. That is a hypothesis, a statement of prediction. At least given the fact that the specification is so we also anticipate that our findings will yield that. Equally, we can still predict that the focal length of lens P is positive, because when they gave us the specification is 8.0, 8 was positive, 12.0 it was also positive. It definitely means that even the focal length that we are most likely to get will be positive. Now when you clearly state the hypothesis, you get a 1. So here we have our 1. Please take note, we had 3 here, we have a 1, we have a 2, making a total of 6. Now after stating the hypothesis, we now go to the list of apparatus. List of apparatus. The list of apparatus, just outline them. What are you going to use in this lab experiment? So 1, we shall need a lens P. We shall need a white screen. We shall need a white screen. We shall need a meter rule. We shall need a lens holder. We shall equally need cross wires. We shall need dry cells. We shall need bulbs. Uh, Basically these ones. So we shall have these apparatus. So you need to have them with you. And then after having them written well there, we shall need to have the arrangement of apparatus. Let us arrange them diagrammatically and then we see. So after having seen a list of apparatus, we shall have arrangement of apparatus. Arrangement of materials or apparatus. Arrangement of materials. So in this case, you're going to have your flat experimental desk. This is my flat experimental desk. We shall have a white screen placed this side. This is a white screen. Then we shall have a lens, which I've called it P. We shall have a lens P in its lens holder. So this is our lens. And then we shall have a wire gauze screen, or a screen that has cross wires. Then we shall have a bulb this side. We shall have a bulb. Which will be connected to either one or two dry cells, and the switch K somewhere, can call it switch K there, and these are dry cells. So you have to label them well. This is wire gauze screen, This is white screen. This is lens P, which I've bought, and then this is lens holder. You're seeing it. Now the distance from where we have the cross wires up to where our lens is placed in the middle here. I want to take this to be the middle of the lens holder here. So we are going to call this distance U, and then the distance from here up to where the screen is placed, or up to where the image is going to be formed, is going to be called V. Now we have that diagram, the arrangement of apparatus. So these were the list of materials that we needed, and then that's how we can arrange them. Now after arranging them, you now need to tell them what to do. In this case, you can call them procedures. Remember, you are reporting, you are giving a laboratory report. So we need now to tell them what to do. How did you come up with this? Since they have told you to go in the laboratory and make a scientific investigation, so you're going to come and report this. However, in these procedures, since it is a report, you can use a tense is so paramount in this. You can use a past tense because you are reporting what happened in the lab or what you did from there. So we are going to come here and say, we are going to say procedures. However, these procedures, you must write them in a logical order, and we shall be labeling them A, B, C, D, E. Why do we have to label them like that? It's simply because we shall reach a moment where we shall need to say that repeat procedure. Now, repeat what? You have to specify repeat procedure from what to what. Now, procedure number A, we shall say arrange the apparatus as shown above, where as I have arranged them. That is our A, arrange the materials as shown above. Now D will be measure distance U equals to 30.0 centimeters using a meter rule, and place there the length P. This length P is going to be at a distance U equals to 30.0 centimeters from the cross wires. And the cross wires are going to act as our object. And then the distance from where this wire goes screen is placed up to where the lens is going to act as the object distance. This is our object, and then this is the objective distance. Now, the image will depend on where the object is placed. So the image distance is dependent, and then the object distance is independent. And that one, we've already seen that. So, adjust distance U, that is between the wire gauge screen and the lens P, to be equal to 30.0 centimeters. Why, you may wonder why I'm putting 30.0 centimeters. That one, I will talk about it after. It comes as a result of the instrument you use to measure. So each instrument you use in physics here has its level of accuracy. So you realize that when you write 30 centimeters, it may not bring out the meaning to its real sense. So procedure number C. Now you're going to complete the circuit, or you're going now to close switch K so as the bulb gives light. So you say close switch K so as the bulb gives light. This is our torch bulb. You've connected it well. And then when you complete switch K, when you close it, it will definitely give light. And according to the law of propagation of light, you said that light travels in a straight line. And now, given the fact that these diagrams are well arranged in a straight line, I expect the light from here to still move in a straight line. And so it will be incident on this lens P. And since this is a convex lens, the convex lens, it is still called a converging lens. So it will try to converge all light that are incident on its reflecting surface into one point to form an image, as we are going to see it practically. Now, your procedure number D will be move the screen to and fro. You're going to move it to and fro, to and fro, to and fro. So you adjust it, you move it towards the lens or away from the lens until a sharp image of the crossed wires is formed on the screen. In this, we are looking at where the image is going to be formed. So we are going to move this screen here to and fro until we get a sharp image of the cross wires, which is now the object. So until we see the sharp image of these cross wires forming on the screen. When that is attained, then we stop there and then we measure distance V, and that is from the lens P up to the white screen, and we are going to call it V. This V is the image distance, which is the dependent variable. Okay, but we realize that we need plotting, and only one value is not enough. So we need to repeat this experiment, one for clarity and also to improve on our level of accuracy. When you simply It's for example, if say maybe I find you revising in a room for once in a day, uh, I cannot conclusively say that so and so person A revises books, not until I find you more than 2 times. I can find you in the morning, in the evening, even the next day and the other week. There I can categorically uh, have the guts of saying that so and so has the reading culture. But when I find you just once, I cannot conclude. So we repeat this experiment to improve on the level of accuracy. So we need to be accurate enough. And so what are we going to do? We are going to repeat the experiment for other values of u, for other values of the object distance. Now we are going to say, repeat the experiment for other values of u equals, we begin with 30, so 40.0, 50.0, 60.0 and 70.0 centimeters. Repeat procedures from B to E. Repeat procedures from B to E. Remember, procedure B was measure or adjust distance u to be equal to 30. So the next experiment now, we shall be adjusting it to 40, to 50, to 60, and then we get the corresponding image distances. Okay, so after now reading this, we realize that we need to put them in a suitable table. So we have to put them in a suitable table, but again in that table, we need to include some other values. And then, how are we going to get all of that? We need to record our values in a suitable table, including values of what and what. They can always give you a hint or they may not. They may give you a hint or they may not give you a hint. But if they don't give you a hint, how are you going to plot the graph? What against what? You need to have a variable on the y-axis and a variable on the x-axis. It's incumbent now upon you to choose which one which one are you going to put on y-axis and x-axis respectively. You need to have the theory of the practical before you do the practical. So much as these experiments are simple, you also need to have the theoretical knowledge of physics. I'm now going to borrow the idea from the Miller formula or from the Lenz formula. From the Lenz formula that 1 over f is equal to 1 over u plus 1 over v. We are looking for what are we going to plot, what are we going to put on the y-axis and x-axis respectively. So I want f, this is the Lenz formula, where f is the focal length of the lens that we need, u is the object distance, and v is the image distance. Now 1 over f equals, this is the, when we get the LCM, this is uv, and then up here we shall have u plus v. But then I'm interested in f, not 1 over f. That means if the reciprocal of focal length is u plus v over uv, then f alone will be equal to uv out of u plus v. When this somersaults, also the left will even somersault. Now we have f equals to uv over u plus v. That means the one that is up here, it is going to be plotted on the y-axis, and then this is x-axis. Now we are going to have our next procedure here, a, b, c, d, e, f. We are going to say, record your values in a suitable table, including values of u plus v and uv. We shall include values of uv and u plus v. Record your values in a suitable table, including values of uv and u plus v. Why do we need to include these values? It's simply because they are going to help us to plot the graph just from the Miller formula or from the Lenz formula. So it's a Lenz formula because now we are dealing with the lenses, much as it is still called the Miller formula, and the letters are still defined in that manner. Now, after that procedure, now we have to go to G. Procedure G, we've recorded our values in a suitable table, including values of UV and U plus V. Up next is what? Now, we need to plot a graph. So you say plot a graph of UV, plot a graph of UV against U plus V. After plotting the graph, definitely we shall need to find the slope. So we shall say GH. So determine the slope of the graph. Determine the slope of the graph. We can call the slope, slope F. Then finally, I we say the focal length, the focal length of the lens, is equal to slope F. So when you get the F, when you get the slope of the graph, it will be equivalent to the focal length of the lens because F was equal to UV over U plus V. So when we plot this against that, the slope will give us the focal length. Now, we are going to practically see this, and then we thereafter look at how best we can perhaps get these values. However, you need to have now data analysis, but before even that, we need to look at the errors identified and then their mitigations. Now, these errors identified and their mitigations, they can actually come after the table of results or they may come before, because we may identify some errors along the process of doing it. So we can now have data analysis. Under data analysis, we shall have table of results. Table of results. And now in the table of results, you have to begin with the independent variable in the first column, and the independent variable was object distance U, and you have to put the unit it is in centimeters. Then the moment we have U, we shall always get V, which is the image distance, still in centimeters. It is very, very paramount to put the units and should be written in small letters. The moment you don't put the units, we shall cross and you'll be losing out some marks. So some scores. So you don't need to miss out this. When you write U, put U in what? If it is in meters, put in meters. If it is centimeters, use centimeters. So in this case, I'm going to use a centimeter. So U in centimeters, V in centimeters. Then we shall, we've said in our table, include values of UV and U plus V. So we shall have another column of UV. Now, the unit for UV, if U was in centimeter and V was in centimeter, UV simply means centimeter times centimeter. And now the unit here will be centimeter squared. And finally, we have said include values of UV and U plus V. So U plus V, for it will have a unit as centimeter. Why? It is just a centimeter plus a centimeter, which is equal to a centimeter. Thank you. Okay. Now, after having your table here, but make sure you are so neat, you should cross out not anything untidy will lead to loss of scores. So just need to be very, very neat when you're handling this. Avoid crossing out. And now, we began with 30.0. We went to 40.0. We have 50.0. Have 60.0, we have 70.0. You can add more. However, you need to at least have a minimum of 5 points such that you are able to plot. 1 point is enough not for you to come up with a clear graph. So you have to be with a minimum of 5 points and maybe maximum of 7. Don't be too long and too short. Don't be too brief and again too naughty. So I'm going to use 5 points here. So now, hope you now seeing my graph. However, when it comes to this table of results, we don't just fill in. We have to consider what we call significant figures and decimal places. And now, this is a theory of the practical. So you need to have a theory of the practical before you do the practical. The decimal places and significant figures, it is also another lesson that you go subscribe on Moto Online. Everything is there. Now we've recorded these values to one decimal point as we are going, as you are seeing, 30.0, 40.0 up to 70.0. It is one decimal place, simply because the instrument that we are going to use to measure this length here, it is a meter rule. And a meter rule, I told you that the level of accuracy depends on the instrument you're using. For a meter rule, for values measured using a meter rule and you are recording them in centimeters, they must be recorded to one decimal place. And if they are recorded in meters, you are supposed to record them to 3 decimal places. Now, we are going to measure you using a meter rule, and so we are going to record these values in one decimal place. The same will apply to V. V is also going to be measured using a meter rule, and still we shall have to record them to one decimal place. Are you seeing? You can put them down here to simplify your work during calculations. So now, one decimal place, one decimal place. Now, from there, we have UV, but UV is multiplication. And again, under multiplication, we have, under laws of significant figures and decimal places, we have what we call addition hyphen subtraction rule. Addition, subtraction rule. And then rule number 2, we have multiplication, division rule. Multiplication, division rule. When we are adding things or subtracting things, our emphasis is only on decimal places. Decimal places. When you see addition or subtraction in a table of results, our emphasis will be put on decimal places. And in this, you learned that if we have 2 decimal places plus 3 decimal places, we shall always record our answer to the one with the least number of decimal places. So 2 decimal places plus 3 decimal places, our answer would be to 2 decimal places. 1 decimal place plus 2 decimal places, our answer would be to 1 decimal place. However, 2 decimal place plus 2 decimal place, we shall have 2 decimal places. Well, so then multiplication division rule. For this, it is the emphasis is put on significant figures. Multiplication, addition, significant figures. Addition, subtraction, decimal place. Significant figures. The same rule. 2 significant figures times 3 significant figures, our answer will be to the one with the least number of significant figures. So we shall have our answer recorded to 2 significant figures. For example, if I say 2.1 times 2.32, these are 2 significant figures, these are 3 significant figures. My answer should be to 2 significant figures. A round off, and hope by now you know the rules of rounding off. Figures from 0 to 4, we add a 0 to the target value. Then figures from 5 to 9, we add a 1 to the target value. Subscribe to Moto Online. You enjoy more of these practical lectures. Okay, now UV. Now I'm not going to fill this now because I don't have V, and UV is multiplication. However, these are 3 significant figures, so I don't know the V. When V is also 3 significant, that means I will have 3 significant times the 3 significant figures. And now my answer will be recorded to 3 significant places. And now I only choose the largest value. In this case, this is a 70. If I multiply with its value of V here, supposing it is also to 3 significant, my answer will be to 3 significant. Only test this last part here. Then, if, for example, it gives me 140, these are 3 significant figures, and you are seeing, decimal place. That means the whole of this column now will be recorded to 0 decimal place because the target value that the testing value has given me 3 significant figures, which was my target because I'm dealing with multiplication. I only have to test the largest value. When I test it, 3 significant times 3 significant, I have to get 3 significant. So if it gives me maybe 140, these are already 3 significant figures. And now, when I look at it, it has 0 decimal place. So this column will be equal to 0 decimal place. Don't bother to test